Saxon Algebra 1, greetings, my students. Oh gosh, I'm so happy you're here today. This is a lesson that we are going to use on the daily from here on out. It is a super practical, super useful, tiny little tidbit of a lesson, and it's got a great story with it. What I want you to know is that if we are multiplying two square roots, this is a made-up number called m, this is a made-up number called n, we can put them together. Or, vice versa, if we have two numbers that are being multiplied together, if we prefer, we can break them out separately. This is called the products of square roots rule, which I think is a really boring name and no one's going to remember it, and it puts me to sleep just saying it. I can only imagine you're dozing off right now listening to it. Okay, wake up, because I have something more interesting to say. This fact, this little situation here that I want you to bury deep in your brain is actually the story of the Three Little Pigs. The Three Little Pigs, as you may well recall, is a story of three little pigs who are brothers. They set out, presumably from a shared home, to seek their fortune, and they each build themselves a new little house. One little house is built of straw, one is made of sticks, and the third guy goes ahead, places an order for bricks from Home Depot, and builds his home from brick. This is illustrated thusly. See, these are little pigs living in their little pig houses separately. But what happens when trouble comes in the form of a wolf? He doesn't say fee, fi, fo, fum, does he? That's Jack and the Beanstalk. I'm mixing my metaphors. How ridiculous. But what happens is the wolf comes along and he starts blowing down the houses, the flimsy one at least. And what do the pigs do? They run to each other's homes and huddle together in the increasingly stronger homes. And then, presumably, after they all end up together, and the big bad wolf, I think some versions of the story sugarcoat it, but he comes down the chimney and they cook him in a pot. He dies a boiling death. Then they're free to go out and create their own homes again. So this I am going to refer to as a pig house and pigs inside of the house. All right, so this is actually called a radical. These numbers we refer to usually as square roots, but I'm not going to call them that. I'm going to call them pig houses, and these are going to be pigs. All right, so let's do some examples. By the way, in case you're looking for a diversion someday, on my YouTube page, I have a playlist called Mathiness, I believe, and I keep videos there that relate to these ridiculous metaphors that I use. I believe there is a animated version of the Three Little Pigs. I think I ended up posting the old Disney short. So if you're in the mood to watch the Three Little Pigs, or if you're not familiar with the story, if perhaps you're not from the culture that teaches the story of the Three Little Pigs to their youth, by all means, check it out, because I'm going to be talking about it forever. Square root of 50. Okay, this we can break down, right? It kind of represents this form, right? Where we can break this down into factors. And our first step in doing that is let's just make a factor tree the way we've done for a million years. We're going to break out the prime factors of 50. Okay, it's 5 times 10. 5 is prime. 10 can break down into 5 times 2, and those are both prime. So I'm going to rewrite square root of 50 as the square root of 5 times 5 times 2, because those are the numbers I circled, right? So these are the prime factors of 50, and I've made this look a lot more like this, haven't I? I've broken out the factors. Now, here's a rule. 2 pigs in the house equals 1 pig out of the house. I could extend the story of the Three Little Pigs to try to make sense of that, but I'm not going to, because sooner or later, every metaphor breaks down, and I don't want to make your brain crazy. But that's the rule. 2 pigs in the house equals 1 pig out of the house. That's good math too. I'll explain it to you in more details later, but right now I just want you to understand the story. So this equals 5 on the outside, and this 2 is left over on the inside. This is the final answer. These 2 5s come out as a single pig, and there's our simplified version of the square root of 50. Oh, right? I'm going to explain this rule to you later in this lesson, but I don't want to do it right now. I want you just to get used to seeing how it works. Square root of 200. Again, the first step is to break the number down into its prime factors. I'm going to go 20 times 10. 10 I just did. It's 5 times 2. Those are both prime. 20 is 4 times 5, but I'm thinking ahead, so I'm just going to go 2 times 2 times 5, because these 2 make the 4. And then there's the 5. So I can rewrite the square root of 200 as, I'm going to put them in order, 2 times 2 times 2 times 5 times 5. All right, I see multiple pairs of pigs. Here's a pair of 2s. 2 on the inside is 1 on the outside, so I'm going to write a little 2 there. And then a pair of 5s jump out as a 5. We multiply. The pigs, if we jump multiple pigs out of the house, we multiply them together. So our final answer here is 5 times 2. That's 10 on the outside. And what do we have left on the inside? Just that single 2. Yay! This kind of simplifying, we're going to do a lot in our future lives. Example 63.3. Did I slide out of the camera? Yeah, a little bit. Okay. Now sometimes, I mean, you know how to find prime factors of numbers. Sometimes it's a little trickier. We have to use a little bit of deductive reasoning / detective power to figure out what numbers multiply to that. I don't know offhand what multiplies to 147, so I have to think. Is it 2? No. This is not an even number. So 2, 4, 6, 8, all those numbers go right out the window. It doesn't end in a 5 or a 0, so I know it's not 5 or 10. What about 3? In order to do 3, what we do, remember the rule is we add the digits. 1 plus 4 plus 7, that's 5 plus 7 is 12. If 3 goes into the number that they add up to, then 3 is going to go into this. And it does. 3 goes into 12. So I know that 3 goes into 147. I know that's a really weird test. I don't know why that works, but it does. So I'm going to take 147 and I'm going to divide it by 3 and see what I get. 3 into 14, well, 3 times 12, or 3 times 4 is 12. Remember, we multiply, that's what I have there, and then we subtract and we bring down. Ooh, 3 into 27 goes 9 times. So what this tells me is that 147 splits. I'm going to do a sideways split. 3 and 49, and 49 is 7 times 7. So I know that the square root of 147 equals 3 times 7 times 7, right? I figured that all out over here. Notice how my notes and my calculations, they're part of the problem. I'm not scratching them out or trying to hide them. They get to live in the middle of this problem. They are legitimate parts of my work, and I should be proud of them. Some students really hate having those sort of side calculations in the middle of their problem, and what I suggest to them is draw a box around them. Put them to the side if that really bothers you, but do not do them on scrap paper and throw it out. That is not okay. All right, so here we go. We have a pair of 7s. They hop out, and we get our final answer, 7 square root of 3. Many, many times in the future, we will be simplifying radicals and then leaving our answers in this form. We could take a calculator and get the answer to that, but we don't want to do it that way. We want to just live with the radical signs. That's perfectly fine. Next one, 108. Well, that at least is an even number, so I'm going to do 2. And in my brain, I divide that number in half. I get 5 and 4. 2 is prime. 54, I recognize that from my times table, 6 times 9. I remember so clearly the day in 3rd grade that we first approached our times tables. I was so excited. I know, that makes me a little weird. But I just remember it. We got to decorate it, and I made mine with like vines and little pink flowers all over it. I really got into the art of that. Okay, 2 times 54. 54 is 6 times 9. I break down both of those, and now I'm ready to list all of my piggies in their house. I'm going to do them in order. 2 2s, 3 3s. 2 times 2 times 3 times 3 times 3. By the way, this is exactly the way I want you to do it in your homework. Show your calculations, break it down, list it out. Later, we'll get a little faster, but right now I want you to do it painstakingly. So we're bringing out a 2, and I want you to draw the little arrows just like this. 2 times 3 is on the outside, so that is 6. Square root of whatever's left, 3. Yay! Okay, that is the last of these problems. So I'm going to show you why that pig rule works. 2 pigs in the house equals 1 pig out of the house. And then I just have one more little section that I need to add to this bit that we've done, and then we'll be done with our lesson. Okay, square root of 16. We know just by looking at it that the square root of 16 is 4, right? But let's pretend we didn't know that. Well, what would we do? We'd break this down into 4 times 4, and then we'd break it down into 2 times 2 and 2 times 2. Then we'd write all these factors here, wouldn't we? 2 times 2 times 2 times 2, because those are, I didn't circle them. Those are all the prime factors of 16. Then we would say 2 pigs in the house equals 1 pig out of the house. I could have chosen an easier number, but I didn't, so whatever. And I would bring out 1 pair. Oh, I'd bring it out here, not way over there. I'd bring out a 2, and then I'd bring out another 2, wouldn't I? 2 times 2, those 2 2s right there equal 4. And look, I get the very same factoid that we started with. So 2 pigs in the house equals 1 pig out of the house. You can bring out multiple pigs and then you multiply them together to get your answer. And with that proves what we already knew, that the square root of 16 is 4. So that's the rule. 2 pigs in the house equals 1 pig out of the house. If you pull out multiple pigs, multiply them together. All right, last thing is just a little memorization work that I want you to write in your notes and start jamming into your brain. Memorizing is a process, and so I don't demand memorize this in the next 25 minutes. That's not how our brains work. It takes time. It takes 10 years to get information into long-term memory. Yes, I said 10 years. So if you're still working on trying to remember your times tables, that's because you haven't known them for 10 years yet. And then the other thing is that in order to shove something even relatively deep into your short-term memory, you have to hear it 7 times. Yes, I said 7 times. I know I repeat myself in these videos, or I'd repeat myself in person if you were with me. That's why, because even though you remember hearing it, you don't remember the information. None of us do. This isn't just like about teenagers or anything like that. This is the human brain as it's been studied. 7 times we need to hear something before we really own that information, even in the short term. So, do I repeat myself? Yes. Is there a method to my madness? Heck yes. So, anyway, here's what I want to tell you. Some fractions, when we convert them to decimals, repeat. Like this, right? We write it like this. What it really means is 0.3333333, and so on. We don't want to write this, so we write that as shorthand. 1/3 equals 0.3 repeating. Thus the topic, repeating decimals. 2/3 equals 0.6 repeating. Yes, it equals 0.6666666. So we memorize it like that. 1/6. Notice that the relationship here we double, right? The denominator or the numerator. Denominator stays the same, but the numerator is doubled from 1 to 2. And look what happens to our decimal. It doubles also. These two are easy to remember together. 1/6 equals 0.16, and then the 6 repeats. Notice that I'm not rounding these, I'm writing them as repeating. Rounding them would be different. If we wanted to round this, we'd round it to 0.7, wouldn't we? We'd round this to 0.2. So I'm not rounding these, I'm writing them as repeating decimals. And then the last one, 1/9 equals 0.1, and the 1 repeats. So this is the only one where there's a non-repeating decimal and then the repeating part. I want you to memorize these. Remember, this is 0.1, and then the 6 repeats, and 9 is 0.1. I want you to remember what they look like. I want you to remember that this is not rounded. This is just the shorthand way that we write this. If you want to round it to the nearest 10th, 100th, 1000th, whatever, you use our regular rules for rounding, right? You circle the digit you want to round to, you put an arrow to the next one, and then you say, is this one between 0 or 4, or 5 and 9, and then you either stay or go up respectively. That's how you round. We're not rounding, we're just writing as repeating decimals. So this is what I'm asking you to memorize. Write this where you write your important things to memorize. Please tell me you have a place. I'll be sad if you don't. And the other thing you can put there from this lesson is put this little story about the pigs and write 3 little pigs. And I'm completely serious. If you're in the mood, or if you grew up in a culture that does not share this story, please check out that video on my playlist. It's called Mathiness. It's got all of my weird random metaphor videos. So that if you don't know what I'm talking about when I say something like the kingdom's collapsing or the 3 little pigs, then you can go and see what I mean. Because I'm going to talk about this a lot. Okay, guess what? I'm done. That's all. Thank you. Goodbye.